The next question is, we've talked about being able to scale and being able to deliver as fast as the market demands. But there's a caveat in there. If we are big and we are fast, but we don't have security, it's dangerous. Oh, it's dangerous. The way that we used to do that, where the security only comes at the end of the development, when you have done all the efforts, and then that's just when you check the security, is actually, it could cause us a big delay. So the right approach is to actually embed security in every phase of the software development. You use security as a guardrails, and with that, you make it as an enabler. Because especially when you're agile, that means you are fast to deliver. There will be limited time to test, and if you only do the test at the end, then that would it could really make or break. No, because the security could just decide, no, you have to rework it completely. But the right approach is, for example, we have here again the phases of software development. On the requirements phase, let's say you evaluate the use cases. If you're building, for example, a CRM system, so your requirements is to be able to get, for example, the customer data. And if you want to pass it to a payment system as well, then you need to also get their payment information or banking information. But when you have identified these requirements, then you also need to identify abuse cases, right? Uh, I'm sure it's quite practical. You would have experienced that as well. What if, for example, I order online in the website, and then at the same time I'm ordering the same product in my mobile phone? So which one will happen? Will I have two products and all? And what if I pay cash in the other device and pay using credit card in the other device? Or how will the system respond? So you identify abuse cases, and from those abuse cases, you define, now you add security requirements, and you add those requirements, you try to translate it. How do we now trap them in our build, in our codes? You do risk analysis from your security requirements and from the abuse cases, and you bring it to your architecture and design. So every step of the way, there's a way to integrate security in it. When you do, for example, the code review, so what you do is you do pair coding. For example, you use tools like static code analysis. You use dynamic tools as well, like dynamic application security testing tools, and you continuously assess the risk. So a bottom line is, the DevOps, it can only survive if security is integrated, especially in this era now where even nations are playing against nation. It's sad, but it's true. Uh, So what we wanted to say and to emphasize is, actually security should sit with the development team from day one. If this is not happening in your organization, then it's time to change that. And how do you do that? How do you actually um, integrate security from day one? Or what if you already have an existing application and you just want to secure it, to add security components to it? So what we want to suggest is actually to mitigate the risk from the drawing board. You literally just need to start with a whiteboard or pen and paper. You can start with a process that's called threat modeling. We are showing here STRIDE, and STRIDE stands for spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privilege. These are usual threats. You have definition here, like someone is impersonating something or someone, and you map it with the desired property. And our desired property evolves mainly on the confidentiality, integrity, and availability. You also want to have authentication and authorization and non-repudiation. For some, it could be a, a tongue twister already, but repudiation is that someone could not really deny that she did something or he did something, you know, if there's some malicious activity. So the threat modeling identifies the threat and vulnerabilities before you even start coding. That if you're making an application from the beginning, before you even turn on your computer, you do the threat modeling and you try to identify already what could go wrong. So that's these are basic questions that you ask to identify um, the security threats and vulnerabilities. First, you need to understand what are you building. Are you building a cashier system? Are you building a payment system? Are you building just a portal so user or customer could see products? And then when you're able to understand what you want to build, you start asking yourself what could go wrong. If you start, if your page would have a user authentication, what could go wrong in there? Could the user input something else so it also sees the entire database of your user? This kind of things is what we want to avoid. And then you continue to evaluate along the process of software developments. What are we going to do about that? How can we prevent that? And you also need to evaluate, did we do enough good job in there? If not, then let's try something else. Let's try another approach. So this is a continuous process. And as you have seen, as you have heard, it's really just a change of mindset. We need to start we need to start considering the although we are good people, there are bad people among us. And we need to trap how these bad people will try to attack us and how we could prevent that from happening.